All right, pre-cal, this is lesson 2.5, factor solve and graph polynomials. So we did factor solve and graph quadratics, but now we're looking at higher order polynomials. And this has got to be my favorite section because there's just such a strong connection between factor solving and graphing polynomials that we want to just make sure you know cold, because knowing the shape of a polynomial is really, really powerful. So we're going to incorporate all the methods of factoring that you already have learned, which is factor by grouping, looking for greatest common factor, and what we were just doing in the previous lesson, quadratic form models. So tonight's homework is a little factor and graph polynomials worksheet. It's really fantastic. You're going to love it. So example 1, factor, solve, and sketch the polynomial. And you'll notice I said sketch. You have a graphing calculator, and it allows you to graph, but it's so much faster when you can just see it in your head. And so being able to do it in your head is really, really important. But you don't need a perfect graph. I'm not looking for the maximums and minimums on your curve. I am simply looking for the roots or the solutions on the curve. So here we have a higher order polynomial. You can see it's x cubed, and you'll notice that there are 4 terms here. Anytime you have an even number of terms, or which we're going to do a worksheet later where you'll factor using with like 10 terms. It's ridiculous, but totally cool. We have 4 terms. Anytime you have an even number of terms, you can do factor by grouping. So I'm going to do factor by grouping, sort of part them into groups of 2, and I'm going to look for the greatest common factor here. So the GCF in front is x squared, and when I take out the x squared, it leaves behind x plus 3. Looking at the last 2 terms, we have a GCF of -4, and when I take out that -4, it's going to leave x plus 3. And now we've shrunk 4 terms is now 2 terms, and they have a GCF. So once again, they both have this x plus 3 term, and it leaves behind x squared minus 4. Well, x squared minus 4, double bubbles, that's difference of squares. And so we get x plus 2 and x minus 2. And this is completely factored. So once we completely factor our polynomial, then we can see the zeros. When you set it equal to 0, you are finding the zeros of the graph. Well, to do that, you just set each bubble equal to 0. Well, that's pretty easy to do. It turns out x equals -3, x equals -2, and x equals +2. And these are the x-intercepts. So I can graph those x-intercepts. I have a -3, I have a -2, and I have a +2. And you'll notice you plot a point and you label it. It is what it is. It doesn't matter how wonky the spacing is. I'm telling you, that's what it is. Now, how do we graph this? A polynomial is a nice, smooth curve. And this polynomial is positive, has a positive leading coefficient, which means it's going to start low and it's going to end up high. It's going to be an increasing function overall. So just like a positive slope goes uphill from left to right, we also want to go uphill from left to right. So we're going to start down low, and we have to then cross each of these zeros. Up, return, and go back through. There you go. There is a beautiful polynomial. If you're not sure, use your calculator. When in doubt, graph it out. Mrs. G's favorite saying. Delete. So we're going to test this. X to the 3rd plus 3x squared minus 4x minus 12. So you can check all of these. Oh, that bad graph. Let's do my viewing window. I want to go back to my standard window. Okay. So there you go. And so you can see how it's crossing through -3, -2, and +2. Those are, you can't see that at all. There you go. -3, -2, and +2. So there is our nice, smooth polynomial curve. We like to call these roller coaster curves. They're super fun. All right, here I have 3 terms. Of course, the very first rule of thumb is always look for a greatest common factor. So when I look at this, I see they all have an x, and I definitely want to take out the negative. So I'm going to take out a -x. When I take out that -x, I'm going to be left with x squared plus x minus 12. And now I can double bubble this quadratic. -x. So I'm going to double bubble here. X times x is x squared. What times what is -12? +4 and -3. How do you know if you did it right? Check the rainbow. -3x and +4x gives us that +1x in the middle. Now we want to find the zeros. We set it equal to 0, which means we're going to set each factor equal to 0. Well, -x equals 0. Divide by -1, so x equals 0. That is one solution. Here, moving over the 4, we get x equals -4 and x equals +3. So yes, when there's an x that you can take out, it is a solution that is 0. So I'm going to make a sketch. So 0, -4, and +3. Label, very simple. Now, you'll notice the leading coefficient here is negative. It is a negative leading coefficient, which means this is a downhill function, going downhill overall from left to right. So this one starts up tall on the left and then passes through in a nice smooth fashion all 3 zeros. Fun. And again, when in doubt, use your calculator. But I need to see all this work. All right. So when you're doing the worksheet, I want to see the GCF step. I want to see the set equal to 0 step, and I want to see your x-intercepts and a graph. A very easy sketch. A couple more for practice here. Super fun. These are higher order, even still. These are fourth degree polynomials. I wonder what they look like. All right. This is quadratic in form. Quadratic in form because you can see we have x squared and then x to the 4th. That power of x is doubled. So it's going to double bubble just like we've been doing all along. X squared times x squared is x to the 4th. And what times what is +9? 3 times 3. Or 9 and 1. How about -9 and -1? Now those are difference of squares. So those double bubble even more. X squared minus 9 becomes x plus 3, x minus 3. X squared minus 1, x plus 1, x minus 1. The sum and difference pattern. So this is the factored form, and we can get each solution for x. -3, +3, -1, and +1. These are all of our x-intercepts. And so we get 4 zeros this time. So we have -3, -1, +1, and +3. Very interesting now. This is a 4th degree function. A 4th degree function behaves very similar to a parabola in that the leading coefficient is positive. It's going to open up. Just like a quadratic function, if the a was greater than 0, it was an up parabola. This one is also going to open upward. And so it's starting up high and it's going to end up high. Kind of interesting, but it has to pass through each 0. So it's going to start high on the left And it's going to pass through -3 and through -1 and through +1 and through 3. And look at it's a W shape. That is so crazy, isn't it? I love these functions. They're so much fun. When in doubt, graph it out. X to the 4th minus 10x squared plus 9. Cool, huh? Pretty neato. Now you'll notice how far down this goes. It's very, very low. And we didn't draw it that low. That's okay. I'm not asking you to figure out what that minimum value is. But we also didn't label the y-axis, so it's whatever I tell it is. But we don't need to know that. I want you to understand the connection between the x solutions and the points on the graph. That is the goal here. All right, first of all, we have a GCF. Definitely a -2 can come out. So that would be x to the 4th minus 5x squared plus 4. And now this is quadratic in form again. So we double bubble. X squared times x squared is x to the 4th. What times what is +4? -4 and -1. Those are all difference of squares. So we get x minus 2, x plus 2. And difference of squares here, x plus 1, x minus 1. So our solutions for x are 2 and -2, -1 and +1. So these are our x-intercepts. Can I set this equal to 0? No, that doesn't make sense. It's not an x. It's not a variable that we can solve for. It's a number. So you don't have to worry about that one. All right, so we have -2, -1, 1, and 2. Now, what does this polynomial do? It has a negative in front. All right, it behaves just like the parabola. If it had a negative in front, that parabola was going to open downward. So does this one. So we start low and end low. And that's it, ladies and gentlemen. These are the 4 different ways polynomials can behave. And so they're all the same. And if you can figure out cubics and quartics, then every other polynomial is pretty much the same thing. Pretty cool. So you get lots of practice of this today. I think it's totally fun. And it's definitely something you should show your parents and be like, hey, look what I can do. And then show them on the graphing calculator. And they're like, wow, how'd you do that? Totally impress them. All right. Have fun, ladies and gentlemen.